As we already know, the Earth crust is made of rocks. If you look closely to the rocks, you can see there are many different bits. Some bits are dull, and some bits are rather shiny.
What is a mineral? A mineral is naturally occurring, meaning it is not man-made. Next one, it is inorganic. It has no parts or remains of any plants or animals.
The first example is gold. What is gold? Gold is a yellow precious metal. It has 79 chemical elements of atomic number. It is valued especially for use in jewelry and decoration, and to guarantee the value of currency. Next example is silver. Silver is a white ductile, very malleable metallic element that is capable of high degree of polish. It is strictly monovalent in compounds and has the highest thermal and electric conductivity of any substance. Another example is copper. Copper is a chemical element with a symbol of Cu. It is a soft, malleable, and ductile metal with very high thermal and electricity conductivity. A freshly exposed surface of pure copper has a reddish-orange color. Last example is quartz. It is the most abundant mineral on Earth. It is the name for the large family of rocks, including jasper, agate, onyxes, and flint. Quartz is used in concrete, glass, scientific instruments, and also in watches.
Identifying minerals. In identifying minerals, we have the first property, which is the color. The color is the reason why people are attracted to minerals. Why minerals have color? That is because of the absorption or lack of absorption of various wavelengths of light, where wavelengths may be absorbed or emitted. We also have magnetic properties. Some of the minerals have magnetic properties. First one is ferromagnetism. Ferromagnetism is a strong attraction of minerals to its magnetic field. Paramagnetism is the weak attraction of minerals to the magnetic field. Diamagnetism is where a mineral is repelled to its magnetic field. And magnetism, it is where a mineral creates its own magnetic field. Next one is reaction to acids. Some minerals have reaction to acids, and those are carbonate minerals. And last one is hardness. The harder a mineral can of course scratch the softer mineral. The most scale of hardness is based on resistance to scratching or abrasion. Gangue minerals. Gangue minerals are minerals that contain some metals but are not yet economically mineable. What is mineral resources? It is basically valuable and is useful for profit. Uses of minerals. First, it is used in industries.
Minerals can use in industries. Example of this is calcite. It is used as building stone or construction metal. Another is limestone, used as crushed stone in road construction, for ballast in rail cars, and for the manufacturers of cement.
Next one, in homes.
Homes also use minerals. Example of this is copper, zinc, nickel, chrome, clay, and iron. These minerals is used for plumbing fixtures. Another is stone and bricks. It is used for the place, stove, and furnace. Another is silica and feldspar, used for window, especially the glass.
Hospitals.
Hospitals. Doctors are used as minerals too. There's a lot of places you can find minerals in the doctor's surgery. Example of this is plaster cast, that is made from a mineral called gypsum. Next one is very familiar, thermometer. It is contain mercury that came from an ore called cinnabar.
And generating electricity.
Generating electricity. In generating electricity, minerals can also be used. Example of this is photovoltaic materials. Photovoltaic materials are substances that produce electric current when exposed to light and are used to make solar cells.
Remember, minerals take a lot of time to produce. They are non-renewable. And they can be found easily.
Consider the objects that you use in everyday life. Many of them contain metal. For example, These pots on display in a store are made of copper, a metal which, like all metals, can conduct electricity and is malleable, meaning it can be rolled or pounded into sheets or stretched into wire. While some copper comes from native metal occurrences, meaning that it occurs in a rock as a nodule of solid metal, most comes from ore minerals, minerals that contain metal bonded to other elements. For example, copper can come from several varieties of sulfide minerals. It can also come from carbonate minerals.
What is an ore? It's proven to contain metals that can be mined for a profit. So, when you can find ore, you can find ore in ore deposit.
A place where there's enough ore to make it economical to mine is called an ore deposit. Miners can extract ore from near-surface ore deposits through open-pit mines. Ore deposits that are deeper down in the crust can be accessed by underground mines.
How metallic ores are produced? There are so many ways to produce ore metallic. First is crystal settling, hydrothermal process, pegmatite, precipitation, laser, and weathering and groundwater action.
The first process is crystal settling. Crystal settling. Early formed minerals during crystallization in a magma chamber will promote settling. This settling concentrates the minerals at the bottom of the chamber, which will then become viable deposit as soon as the system cools. Crystal settling is responsible for the concentration of ore minerals rich in dense metals such as platinum and iron. It means crystal settling is the concentration of ore in minerals. Next one is hydrothermal process. When we say hydrothermal, the first thing that bears in our mind is water. What is water? Water is a powerful solvent. It is able to dissolve rocks and minerals given the right pressure and temperature. Hydrothermal process dissolve minerals and forms ions that will later be precipitated back as highly concentrated minerals once the water starts to cool, when it reaches near surface condition. Next is pegmatite. Pegmatite. When minerals grow large enough to populate an area, a pegmatite deposit is formed. Pegmatite formation requires very specific conditions for a particular mineral and are sometimes localized. Pegmatization, formation of pegmatites, brings important deposit of some rare elements such as lithium and beryllium. It also gives a colorful minerals in the world. The next process of how metallic ores are produced is precipitation. Precipitation. When solution lose the solvent carrying the solute through evaporative process, precipitation is most likely to follow, because the solution in itself is already concentrated with ions. The formation of minerals will be easily predicted by the chemistry. Next is placer. Placer. The movement of surface water weathers erodes rocks exposed on the surface. This process operating continuously will be able to decrease the size of minerals and sort them according to density. Stronger and faster rivers have higher energy and are able to carry a variety of sediments sizes compared to slower and weaker rivers. Within the course of river, a bend would imply a decrease in energy which will result in the settling of heavy minerals. The concentration of these heavy minerals will eventually form deposits called placers. And last one is weathering and groundwater action. Weathering through physical and chemical means produce smaller and more stable minerals. The action of chemical weathering liberates the metals in strong bonds to form minerals associated with oxide and hydroxide. Removing the metals in oxide and hydroxide, bonded minerals are easier and requires less energy compared to other bonds. Hence, weathering actually makes the metals in minerals easier to extract later on during processing, because ores can pound the minerals easily. A method that further separates dense sediments from lighter ones is called panning. In this picture, gold, a dense mineral, sinks to the bottom of the pan while the lighter sediments are carried away by water during the panning.
There are many environmental issues associated with these steps.